Okay, hello everyone. So today we will continue to chapter 2, mostly about arrays. Okay, these are the topics that we will be uh, learning. Arrays, what does it mean? By definition, two-dimensional arrays, element by element operations for arrays, matrix operations, polynomial operation using arrays. Okay. So basically, array is the fundamental form of Matlab. So actually, we use to store data. So there are many kinds of uh, arrays. The simplest one is actually vectors. So there are two kinds of vectors. Row vectors, this means they only have one row and multiple columns. The other one we have column vectors. This means multiple rows and only one column. The most popular one will be the matrix. So multiple rows and multiple columns. Okay. Example 1. Let's say we have, okay, please look on the right. So let's say like I put the matrix A. We have so 3 members. Okay. This is the row vectors. Okay. The other one, B equals to 1 semicolon 2, no, maybe 4, 5, and 6. So this is a column vectors, so that easy. Okay. Or we can actually using a kind of shortcut to creating arrays, just like the end of the first chapter. Okay, for example, we can use first term, last term, and step size in the middle, or increment. Okay, or LINSPACE, linspace, first term, last term, number of terms. So remember this, the actual orders. Okay, it will be slightly different. Okay, so I will try it. I say A1, I will generate A1 vector will be the same like A, just using different format. Okay, so will be an array from 1, 2, 3, increment is 1. So the same. Okay, you see the result are the same. Or that this time I will generate B1 using linspace. Linspace. So first element is 4, last element is 6, and 3 elements. Okay, so the results are the same like B vectors. So you guys already know, and please try to generate. Please pause the videos and try this one by yourself using your own Matlab. Okay. Next one. So I will teach you how to enter two-dimensional arrays or typical matrices. Okay. So for matrix, there are many some simple forms. For example, the first one is the square matrix. So this means the number of rows and number of columns are the same. So let's say like we have in this example in the slide we have 3 times 3 rows and 3 columns matrix. The other one we have 4 rows and 6 columns. Okay, the number of rows and the number of columns can be different. To create a matrix is actually quite simple. So let's say like we want to create, let's say this time we want to create the matrix C. Okay, having so 1, 2, 3. Let's say the first row is 1, 2, 3. So 1 space 2 space 3. The second row is 4, 5, 6. So semicolon 4 space 5 space 6. The last one will be 7, 8, 9. So semicolon 7 space 8 space 9. Okay. So the C array, the C matrices will be something like this. Actually quite easy. So please stop, pause the video and try this one by yourself. Next one is the transpose operation. So basically in this transpose operation, the rows will become the columns and the columns will become the rows. For example, we have A now is a row vector. If we put A prime, okay, then it will become column vector 1, 2, 3. Okay, and similarly we currently have B is a column vector. If we put P prime, it will become a row vector like this. Okay. Okay, next important topic is array erasing. Okay, let's say we have our vector A which contain all the elements from 1 to 7. So let's say we want to address the number 3. Okay, so A open 3. Okay, the third member of the array is actually 3. Similarly, we can, let's say like we address number 7. Okay, so A7. Okay, and we can actually do some mathematical operation with that. For example, A2 plus A3, which will be 5. Okay, or we can actually use column. So column is important. For example, let's say like we want to address all of the elements from the array A. So we can do this. Let's say we want to add 1 into all of the array A members. So we can do this. A open colon close plus 1. So all of the members of A will be, previously they are 1, 2, 3 to 7, now becomes 2 to 8. Okay, or we want just to increase the last 4 members of the A arrays. So we can actually do this. A open, okay, 4 to 7, maybe plus 2. So the last will be 6, 7, 8 and 9. Okay, originally A is 4, 5, 6, 7, so it will become 6, 7, 8 and 9. So it's actually quite easy. Please try this one for yourself. Okay, so similarly we can do this for two-dimensional arrays. Okay, let's say we have array two-dimensional array C, which is from 1 to 9, which we have made last time. So this time I want to get the second row, okay, the third column. So it will be 6. Okay, and let's say we minus, we get the second row, third column, and minus second row, first column. Okay, so the result will be 2. Okay, so similarly you can do a lot more. For example, those in the slides, let's say A column 3, so refers to all the elements in the row or the rows of column 3. The second one refers to all the elements in all the columns of row 2 and so on. Okay, the last one, for example, A1 to 3, 2 to 4, so refer to all the elements from row number 1 to row number 3, column number 2 to column number 4. Okay. Next, I want to introduce to you some useful array functions. First one, CAT, open N, A, B, C, and so on. So this function actually help you guys to create a new array by joining array A, B, C, and so on to create a new array. Okay. The second one, find X. So it actually help you guys to find the indexes of the non-zero elements of the array X. Okay, please try to do this at home by using your own Matlab. And length A, so this one is actually calculate the number of elements of A. We will try this one. Okay, so let's say assume we have C is actually 3 by 3. So if I type length C like this, the result will be 3. So let's say length A, the result will be 7. Okay, because A is 7 members. So linked space, you guys already know. Log space, so this one actually generate a row vectors of n numbers, which is logarithmically spaced between A and B. Okay, some more useful functions. Max A, so calculate the max number in the array. Mean A, actually calculate the mean number in minimum numbers. Size A, return the size vectors. So sort A, actually we can sort each column of the array in the ascending order. Okay. So as by definition, max C will calculate the maximum numbers in each column. So the first column, the maximum is 7, the second one is 8, the third one is 9. Similarly, we have mean C, so it will be the minimum numbers in each column. So it will be 1, 2, and 3. Okay. Next one, size C will be 3 by 3, so 3 rows, 3 columns. Okay, so next one we will try the sort function, because originally the C array is already in the ascending order. So I just make the C11 members become 10. So if we sort C, it will become 4. The first column will be 4, 7, and 10. Last one is 1, 4, 7. Okay, the other two columns remains the same, doesn't change. Okay, next, for element by element operations, we can use scalar array addition, we can use scalar array subtraction, or array addition, array subtraction, array multiplication, array right division, left division, and array exponentiation. Actually, these are quite similar to the calculus class that you have learned before in maybe year 1 or year 2. So you guys can follow some example in the multiplication, for example, in the multiplication of vectors, like this example. Actually, they are very easy, so I will not repeat them by myself. Or vector matrix multiplication, like this. Please try this one yourself. Or this example in slide number 24. Okay, some special matrix. So we have null matrix, which is 0. So 0A is actually the same like A0, the same like 0. We also have identity matrix or unity matrix. So I times A equals to A times I equals to A. Okay. So we have some Matlab command that actually helped you guys. For example, the command IN, so it will generate an n column, n rows identity matrix. Okay. Or we can use I size A, so we can generate an identity matrix the same size with the matrix A that we have beforehand. Okay. Or we can use ones n, so it will generate n by n matrix of ones. Okay. Or ones m n, it will generate m rows and columns array of ones. Okay, similarly we have zeros. So zeros n, it will generate n by n matrix of 0. 0 m n is actually generate m rows n columns array of 0. Okay, next please try to plot the function as shown. So fx equal to 10 if x from 0 to 2, fx equal to 0 if x from 2 to 5. So fx equals to minus 3 if x from 5 to 7. Okay, please enter exactly as the slide. So the result will be a step function like this. So it's actually from 0 to 2, the y function is 10. From 2 to 5, it will be 0. From 5 to 7, it is minus 3, like this. Okay. So please pause the video and try to work on this by yourself until you come out to the same result like this. Okay. So the first command x1, so we generate an array from 0 to 2 using the increment 0.01. Similarly, we generate from 2 to 5, then x3 from 5 to 7, and we calculate the respective y value for when x from 0 to 2. So f2 is the y value when x from 2 to 5, f3 are value when x from 5 to 7, and we join the y value of three cases together and x together, and we plot the last function, plot xf. So this one is actually plot two-dimensional plot. So x-axis will be x, y-axis will be f function, so which is our value. Then for more details, we can learn about plot function in chapter 5, which is after the midterm. Okay, last topic will be polynomial operation using arrays. So it's actually similar to what we have covered in the last part of chapter 1. Okay, so let's say we want to find the polynomial roots, then we use command roots a. So a is the array contain all the coefficients of the function that we are interested in. For example, so y equal to roots 1, 12, 45, and 50. So the function we want to find the roots is actually x cubed plus 12x squared plus 45x plus 50. So it has all three real roots, okay, minus 5, and minus 2. You can try this one by yourself. So let's say we have two polynomials, f and g. So let's say f equals to 9, minus 5, 3, and 7. G, 6, minus 1, and 2. So f is actually cube third degree, okay, and g is actually second degrees. So we can do a lot of calculation. For example, we can do f plus g, so the result will be the third degrees. Okay, f minus g, the result will also be third degrees. Or we can do calculation like we can multiply f to a scalar vector, or we can divide g by a scalar vectors like 5 times f or g over 5, like in the slides 30. Next one is how to plot the polynomial's value. Okay, so we use the polyval function, Polyvalx. Okay, a is the polynomial, x is the position that we want to calculate. Okay, please try this by yourself. So we want to calculate the function fx equal to 9x cubed minus 5x squared plus 3x plus 7, and find the value of fx at different value of x from 0 to 4, 6, 8, and 10. Okay, please try this one Please pause the slide if you wanted to. So in this example, I will plot the polynomial fx for x from 0 to 10 like the one in slide 32. So fx equal to 9x cubed minus 5x2 plus 3x plus 7. So here is the accompanying quotes, okay? A equals to 9 minus 5, 3, 7. So x is an array from 0 to 10, but this time I will use smaller increment. So increment is 0.1 instead of 2 like in the slide. So we have more points so that you guys can actually see what happens. Okay, so f equal to polyval a at the value of x. So plot xf. If you guys doing correctly, the result would be something like this. Okay. Okay, as I mentioned before, at the end of each chapter, there will be a lot of practice exercise. So please try to do all of this by yourself. If you have any problems in completing any of those, please feel free to raise the questions in the discussion in the Blackboard or in my YouTube channel. I will try to answer, and if a lot of you have problems, I will give you solutions. Or else, I will assume that you guys can finish them easily. Actually, they are not very difficult. Okay, so from slide number 33 to 34, 35, 36, 37. Please try to do all this by yourself. Okay, that is the end of the lecture. Thank you.